Two green lines appeared in a spectroscope. Not faint, not ambiguous. Clean, bright fingerprints around 4959A and 5007A, coming from glowing nebulae in space. And here's the problem. No element on Earth matched them. So in the 1800s, scientists did what scientists always do when nature hands them a signal with no explanation. They named the unknown. They called it Nebulium, a new element, supposedly living in the vacuum of space, announcing itself with light that no laboratory could reproduce. For decades, Nebulium wasn't treated like a joke. It was treated like a serious possibility, because spectroscopy had earned trust. Spectral lines had become the ultimate chemical fingerprint. Then, in 1927, Nebulium vanished. Not because it was covered up, not because someone erased it. It vanished because one physicist realized something terrifyingly simple. The lines were real, but the element was an illusion created by a measurement tool encountering an environment Earth couldn't mimic. This is a story of a ghost element that fooled brilliant people for 63 years, and a quantum rule that finally solved it. And the reason it matters today is bigger than astronomy. Modern materials science still lives and dies on measurements. Nebulium is the cleanest warning ever written about what happens when you trust one instrument too much. Quick precision check. The periodic table lists elements, not materials. So when people say they deleted a material from the periodic table, what they really mean is a substance was treated like a new element, or a new element was proposed, then later reclassified when better physics and better measurement explained the signal. Nebulium is a perfect example of science doing what it's supposed to do, not defend a belief, correct an interpretation. Now let's go back to the moment this ghost element was born. In the 1860s, spectroscopy was still new enough to feel like a superpower. Bunsen and Kirchhoff had shown that elements produce characteristic spectral lines. Once you saw the pattern, you could identify the element. So when astronomer William Huggins pointed a spectroscope at a nebula in 1864, he expected familiar chemistry. Instead, he saw something that didn't belong, those bright green lines. And that's what made the mystery so compelling. It wasn't we saw something weird. It was we saw a clean fingerprint. In the logic of the era, spectral lines are element barcodes. These barcodes don't match known elements, therefore new element. So Nebulium became a placeholder for the unknown, and it didn't disappear with time. Other astronomers saw the same lines again and again. The signal persisted across different nebulae, different instruments, different observers, which made the question sharper. How could space contain an element that Earth could not? And the answer is where the real science begins, because a mistake wasn't sloppy observation. The mistake was assuming the environment doesn't matter. Nebulium lasted because the logic was good, given what people knew. Spectroscopy had been right so many times that it felt definitive, and multiple confirmations built confidence. If many observers see the same lines, the lines are real. They were. This is a subtle trap. Nebulium wasn't born from fake data. It was born from incomplete interpretation, because spectroscopy doesn't only depend on which element is present. It also depends on temperature, density, ionization, state collision rates, and quantum transition probabilities. In other words, the same element can behave differently when the environment changes. But 19th century physics didn't have the missing concept that would make this obvious. And that missing concept has a name that sounds like a warning label. Forbidden transitions. Forbidden sounds like impossible, but in physics, forbidden usually means extremely unlikely under normal laboratory conditions. Here's why that matters. On Earth, atoms collide constantly. Collisions interrupt fragile excited states before they can emit certain photons. In a nebula, density is so low that collisions are rare. An excited atom can wait long enough for a very slow, very unlikely transition to happen. And when it does, it emits a photon at a very specific wavelength. So the spectral line exists. But your lab might never see it, because your lab is too crowded with collisions. This is a key twist. Nebulium wasn't a missing element. It was a known element emitting a kind of light that Earth conditions suppress. That's why no one could reproduce it in early labs, and why it looked like a new element living only in space. And in 1927, someone finally connected the dots. In 1927, physicist Ira Bowen solved the Nebelium mystery by matching those nebular lines to oxygen in a highly ionized state. Specifically, the famous green lines were explained as forbidden transitions of doubly ionized oxygen, written as O3 in astronomical notation, the moment the oxygen explanation fit. Nebelium didn't get erased. It got replaced because the better model won. And that's the real meaning of deleted from the periodic table here. Not censorship. Correction. The observations were right. The label was wrong. This is one of the most beautiful scientific outcomes possible. The universe didn't change. Our understanding did. Now here's the bigger lesson that makes this a Future Forge story, not just astronomy history. Nebelium is a warning label for every modern lab, because today we still make the same mistake, just with better tools. We see one strong signal, and we want a clear conclusion. But modern materials science learned the hard way, no single tool is enough. A spectrum can mislead you because of oxidation state, overlapping peaks, contamination, sample prep artifacts, instrument calibration. That's why real labs cross-check. Multiple spectroscopy methods, microscopy, compositional analysis, and repeatable sample prep. Nebelium is the historical reason this mindset exists. The data wasn't fake. The interpretation was incomplete. That line applies to a shocking number of modern breakthrough claims too. And it's why confirmation culture matters. Which brings us to how element discovery works today. If Nebelium happened today, it wouldn't survive for decades as a new element. Because modern element recognition, especially for super heavy elements, demands rigorous confirmation, repeatable evidence-independent confirmation, clear identification methods, often decay chains in nuclear cases, and a formal naming process. This isn't bureaucracy for its own sake. It's the scientific system defending itself against exactly what Nebelium represents. A clean signal with a misleading interpretation. Today, we don't just ask, what does the instrument show? We ask, what else could explain this signal? That skepticism isn't negativity. It's how science stays honest. Now, Nebelium wasn't alone. It had cousins. Two quick parallels. Coronium, a ghost element, proposed to explain mysterious solar corona lines, later explained as known elements in extreme ionization states. Didymium, once treated like an element in chemistry, later shown to be a mixture of rare earth elements. And that story still echoes today, because rare earth separation and purity control are major industrial challenges. Different domains. Same lesson. When measurement improves, new element sometimes becomes new understanding. Let's close the door on the myths. A committee hid Nebelium. No, better physics explained it. Scientists lied. No, they observed real lines with limited theory. Science is unreliable. No, science is self-correcting, and Nebelium is proof. Nebelium didn't embarrass science. Nebelium taught science what it was missing. So what does a ghost element have to do with advanced materials and manufacturing? Everything, because modern engineering is built on measurement. Trace impurities can change alloy failure behavior, dopant levels define semiconductor performance, surface contamination ruins, thin films misread signals, waste months of research. Nebelium is why we validate with multiple methods. It's why we treat single measurements as hypotheses, not verdicts. And it teaches something deeper. Sometimes a breakthrough isn't discovering a new substance. It's realizing an old substance behaves differently in a new state. That is a heartbeat of modern material science. States, interfaces, environments, and conditions. Nebelium was never an element, but it was real in the only way that mattered. A real signal from real atoms, and it forced humanity to expand what it meant to know matter. That's what Future Forge Explored is built for. Not just new materials, but the moments where science has to rewrite its own assumptions. Because nature refuses to fit inside the first explanation. Subscribe if you want the next chapter. Because next we're going to the opposite end of the periodic table story. The elements that do exist, but only for milliseconds. And the exact experimental standards that decide whether an element counts at all. The future isn't just being invented. It's being clarified.